She had stepped outside because her neighbor called her name. That was all it was. A voice from the driveway next door. Not urgent, not afraid, just a name called across the warm March air in the particular tone people use when they want someone else to come and see something. The woman pulled the screen door shut behind her and walked barefoot across her porch and down the 2 steps onto the asphalt, and the asphalt was still warm from the afternoon. Phoenix holds the day's heat in its surfaces long after the sun goes down. The pavement under her feet was smooth and faintly gritty, and it held the warmth of hours she had been indoors, not thinking about. Her neighbor was already standing in the road, looking north. There were lights in the sky, not the lights of a plane, which move and blink and carry with them a particular sound, the low, persistent drone that you hear before you see the aircraft and continue to hear as it passes. These lights made no sound at all. There were several of them, arranged in a long diagonal line, and they were amber, a warm amber that sat somewhere between orange and yellow, and they moved together across the sky above the neighborhood with the kind of deliberate, unhurried pace that made it seem as though whatever carried them was in no particular need of speed. She stood on the warm asphalt in bare feet and watched them pass. Her neighbor said nothing, neither did she. There was not, apparently, very much to say. Across the city that night, thousands of people were standing in roughly the same position. The date was March 13th, 1997. What the residents of Phoenix observed that evening was later documented through hundreds of witness accounts, video recordings made on home cameras, and reports filed with multiple official bodies. And the event became one of the most widely witnessed and closely documented aerial sighting events in the recorded history of the United States. The lights moved from north to south. They maintained their formation. They produced no sound. People described them from their driveways, from the roofs of their houses, from the sides of highways where they had pulled over to look up. A retired airline captain called them in. A former astronaut would later speak about them publicly. The line of amber lights crossed the warm desert sky from somewhere above the Nevada border and continued south, and the city of Phoenix watched it go. What those lights were has never been established to a standard that satisfies every serious investigator of the case. That remains true tonight, which is part of what makes the evening of March 13th, 1997, worth returning to. Not because the mystery produces anxiety, or because the absence of an answer implies something alarming, but because there is something quietly remarkable about the fact that thousands of people who did not know each other, standing in separate driveways and on separate street corners across a major American city, all looked up at the same time and saw the same thing move overhead in silence, and that the thing they saw has been carefully examined and carefully discussed and remains, in the most precise sense of the word, open. There is a kind of rest in that openness if you let yourself settle into it rather than press against it. Several thousand miles away, and more than 4 centuries earlier, the sky above a German city produced something that people felt strongly enough to document and print. Nuremberg, in April of 1561, was a prosperous city, walled and turreted, its skyline a collection of steep-pitched rooftops and church steeples rising above the river. On the morning of April 14th, before the regular business of the day had begun, residents looking up from the streets reported seeing an aerial display of considerable complexity. The sky above the city appeared to contain a large number of objects simultaneously: spheres, cylinders, objects described as disc-shaped, objects described as crosses. They moved, according to the witnesses, in patterns that suggested something other than simple atmospheric drift. Some appeared to be oriented toward each other, The display lasted approximately 1 hour before the objects appeared to fall to Earth and disappear, trailing what witnesses described as steam or smoke. Hans Glasser was a Nuremberg broadsheet printer, and he documented the event in a printed publication with an illustrated woodcut. The woodcut shows the sky above the city filled with dozens of small circular forms and elongated shapes, arranged with an almost cluttered density above the rooftops and spires of the city. The text accompanying the image treated the event as something genuinely observed, not as allegory, not as invention, but as a thing that the residents of Nuremberg had watched with their own eyes on a specific morning, and which Glaser considered worth setting in type and distributing to a reading public. The document still exists. It can be held and read. The woodcut illustration is detailed enough that the forms drawn in the sky have been classified and counted by later researchers. What those forms were is a question the woodcut itself cannot answer. Glaser interpreted the event through the religious framework available to a 16th century Lutheran printer in a German city, which is to say that he understood the display as a sign, something sent from outside ordinary nature to communicate something to the people below. That interpretation was the available vocabulary of his time and place. What the residents of Nuremberg actually observed that April morning, what atmospheric or optical or other process produced what they saw, is a genuinely open question, and the woodcut and broadsheet remain one of the earliest printed documents in history that attempted to record an unexplained aerial event over a populated city with both visual and textual detail. The sky above Nuremberg did something on April 14, 1561, that the people below found worth stopping to watch, worth remembering, and worth setting into print. The record of their attention has lasted more than 460 years. The attention, in a certain sense, is what endures. In the summer of 1952, the sky above the capital of the United States produced something that ended up requiring a press conference. Washington in July is humid in the way of river cities, the air carrying a weight to it that you feel before you step outside, the heat that gathers in government stone all day, releasing slowly through the night without ever quite finishing. The national airport at that time was a functional civilian airport with a functioning radar system, and on the night of July 19th into the early hours of July 20th, 1952, the radar operators at Washington National Airport observed a set of returns on their screens that did not correspond to any aircraft they had been told to expect. The returns moved. They made maneuvers that the radar operators found difficult to account for. They registered as solid returns, not as anomalies or instrument artifacts, or at least not in a way that the operators could dismiss. When the radar operators called in to confirm what they were seeing, similar returns appeared on the screens at Andrews Air Force Base nearby. The Air Force scrambled F-94 Starfire jet fighters on 2 separate occasions over those 2 consecutive weekends in July. The F-94 was a capable aircraft for its time, twin-seat, designed for all-weather interception, and the pilots sent up to investigate were trained professionals operating under real orders to close with whatever the radar was tracking. On both occasions, the radar returns the pilots were vectored toward either accelerated away before contact could be made or simply ceased to appear on screens by the time the aircraft reached the coordinates where they had been. One pilot reported observing lights ahead of him that he could not close the distance to. The lights moved away, then they were gone. He turned his aircraft back toward the airport and the radar screens below him. At least one interceptor was scrambled twice in the same night. The event prompted the largest Pentagon press conference since the end of World War II. That fact sits quietly and asks to be considered for a moment. Not the largest press conference about aviation matters, not the largest Air Force press conference, the largest Pentagon press conference since the war. Whatever the Air Force had decided to tell the press, it considered the July 1952 radar incidents serious enough to require that level of official public engagement. Major General John Samford, who was then the director of Air Force Intelligence, addressed journalists directly. He explained that the Air Force had investigated the incidents and considered natural atmospheric explanations plausible. He did not, at that press conference, tell the journalists that every question had been answered. The incidents were absorbed into the ongoing Air Force investigation of aerial phenomena, which at that time was already several years old, and they remained among the more carefully discussed events in that investigation's files. Radar returns that the instruments registered as solid, aircraft that could not close the distance, a press conference general enough to gather serious journalists on a weekday afternoon in the middle of summer. The July 1952 incidents over Washington had a texture that official explanations have described and partially addressed and not entirely accounted for, and the records of them are available to anyone who wants to look. What a person does with that information is, of course, their own business. 37 years later, in a country considerably further east, the skies above European cities produced something that put a different kind of officer in front of a different kind of audience. The date when the Belgian wave began was November 29th, 1989, and the first reports came from the province of Liège in the east of the country, not far from the German border. The country is small and densely populated, and the people who observed what they observed that night and on the many nights that followed included civilian witnesses, professional astronomers, and on-duty police officers who filed official reports. The object or objects most consistently described were large and triangular, with a light positioned at each corner of the triangle, and an additional light, larger or brighter, positioned at the center. The triangular shape moved slowly. It made, by the consistent account of many separate witnesses, very little sound relative to its apparent size. Some witnesses reported that it hovered, holding its position above fields or roads for several minutes before continuing. The Belgian Air Force took the reports seriously enough to investigate them with radar and with aircraft. On the night of March 30th into March 31st, 1990, Belgian military radar tracked an unidentified return, and 2 F-16 fighters were dispatched. The radar contact was intermittent. The pilots could not achieve a sustained visual on whatever the equipment was registering. The incident was documented in official Air Force records. Colonel Wilfried de Brouwer, who was then a senior officer in the Belgian Air Force, would later state publicly that what had been observed over Belgium during that period was real, could not be attributed to any known aircraft from any nation, and had not been explained by any investigation he was aware of. That was a senior military officer of a NATO member nation speaking in his official capacity about something his country's Air Force had been unable to identify. What Belgium had was not a panicked population and not an institutional refusal to engage. What Belgium had was something that thousands of credible people observed on multiple separate nights over multiple cities, that ground radar tracked and aircraft investigated, and that a responsible senior military officer was willing to describe in public as genuinely unexplained. The triangular lights continued to appear over Belgian cities through 1990 and into 1991. The Belgian wave was eventually considered closed. The lights had been documented in the thousands of witness reports, in the military records, in the photographs that were analyzed and largely found to be unaltered. Whatever had produced them remained unattributed. The accounts were filed. The wave passed. The sky over Liège and Brussels returned to its ordinary darkness. And then there is the valley in Norway, which does not close. The Hessdalen Valley lies in central Norway, east of Trondheim, a long fold in the mountain landscape with a small river running through it, and a population that has never been especially large. Farmers primarily, people who knew the valley's particular patterns of weather and season, who knew what the sky ordinarily looked like above the ridgelines at night. Sometime around 1981, the sky in Hessdalen stopped looking ordinary. The lights that began to appear during that period were not single-event phenomena, they were recurring. Between 1981 and 1984, residents of the valley reported seeing unusual lights in the sky at a rate that has been estimated at up to 20 times per week. Not 20 times across those 3 years, 20 times per week at the peak of the most intense period. A person living in Hessdalen in those years could, on an average week, look up from their property and see something luminous above the valley floor that did not correspond to any aircraft schedule they knew and did not move the way weather phenomena ordinarily moved. The lights varied. Some were described as white, some as yellow, some as reddish. Some appeared to hover in place for extended periods. Some moved along the valley floor at low altitude. Some were observed to change direction or change apparent brightness without obvious pattern. What they shared was that they were not single, isolated incidents. They formed a pattern, and the pattern was dense enough and consistent enough that serious researchers eventually came to the valley to investigate. Project Hessdalen was established in 1983, one of the earliest sustained scientific investigations into a location where unexplained aerial lights were being reliably and repeatedly reported. Norwegian researchers set up instruments. They recorded data. A small observatory was eventually established in the valley. A permanent automated measuring station equipped with various sensors and cameras designed to monitor the lights without requiring a researcher to be present every night. The lights were recorded. They appeared on camera. They appeared on radar. They produced readings on magnetometers. They were documented with the tools of scientific measurement, as well as the testimony of residents, and the scientific documentation added something that witness testimony alone could not. The evidence that the lights were not merely perceived, but physically present in a way that instruments could register. They also remained unexplained, not unexplained in the sense of mysterious, and therefore assumed to be extraordinary. Unexplained in the more mundane, but more honest sense that no single account, atmospheric, electromagnetic, geological or otherwise, has been accepted by researchers as a complete description of what produces the lights. Various proposals have been made and examined. The valley has unusual geology. There are fault lines. There are specific electromagnetic characteristics to the terrain. These features are relevant to some of the leading natural hypotheses. But the full account of what produces the Hessdalen lights, in their variety and their frequency and their particular behavior over the valley floor, is still being worked on. The lights, for their part, have continued to appear, less frequently now than during the 1981 to 1984 peak, but regularly enough that the automated station still records them, and the data is still collected, and the researchers who study the valley still have new material to work with. The measuring station sits in the valley in the dark. It sits there in winter when the ridgelines are white and the valley floor is hard with frost, and the sky at night is very clear and very large above the narrow walls of the landscape. It sits there in the shorter, lighter nights of summer when darkness in those latitudes is barely darkness at all. It sits there when no researcher has driven out to check on it in weeks, its instruments running their scheduled cycles, its cameras oriented toward the stretch of sky above the valley where the lights have most often been recorded. When a light appears, the station notes it. When the light's intensity fluctuates, the instruments track the fluctuation. When the light holds its position above the valley floor for several minutes and then moves, the sensors register the movement and the time and the direction. The data accumulates. The record grows. There is something in that image that is worth sitting with for a moment on this particular night. The idea of a set of instruments stationed quietly in a Norwegian valley, patient and attentive, recording whatever appears above them without alarm, without conclusion, without any particular investment in what the lights turn out to be. The station does not care whether the lights are natural or unnatural, familiar or novel, simple or complex. It records them with equal attention regardless. It has been doing this for decades. It will do it again tonight. The thing that connects a woman standing barefoot on warm Phoenix asphalt in 1997 and a 16th century Nuremberg printer setting a woodcut illustration in type and a radar operator at Washington National Airport watching a return move across his screen in ways he did not expect, and a Belgian police officer pulling over to look up at a large triangular shape moving slowly above a field outside Liège, is not that they all saw the same thing. They probably did not. The atmospheric conditions were different. The geographies were different. The decades were different. And what they observed and how they described it varied considerably. What connects them is the act itself. They were all standing on the ground under a sky, watching something above them that they could not fully account for, and they found it worth staying to watch. That is a very old act, and it happens to be happening somewhere in the world on most nights. The urge to come back to the Hessdalen station specifically is not accidental. Most aerial sighting events are single occurrences. One night, one city, one set of witnesses, a record that was made and then largely closed. Hessdalen is different because it did not close. The lights came back. They came back on the following night, and the night after that, and the night after that, for weeks and months and years. And they eventually attracted the kind of sustained attention that only comes when something keeps presenting itself to be looked at. The researchers came with their instruments, and the instruments confirmed that there was something to measure, and the measurements were careful, and the conclusions were honest. This is real, and we are not entirely sure what it is, which is, in a certain sense, the most useful thing a careful investigation can produce. Not certainty, where certainty is not yet warranted. Not a closed file on something that remains open. Just this is real, and we are working on it, and the work is ongoing, and the data is growing, and we are paying attention. Somewhere in central Norway tonight, an automated measuring station is doing exactly that. The sky above the Hessdalen Valley holds whatever it holds on any given night. Clear sky, or cloud, or the particular deep dark of a mountain valley in the hours after midnight. The station's sensors run their cycles. The cameras face the stretch of sky above the valley floor. If a light appears, the instruments will note it. If the light moves, the direction will be recorded. If the light holds its position for several minutes and then shifts, that too will become part of the record, added to the years of data already collected, adding one more entry to a collection of observations that has been accumulating since the early 1980s, with no particular expectation of resolution and no particular need for one. The record simply continues. That is what serious attention looks like when applied to something that has not yet given up all of its answers. Not urgency, not alarm, not the pressure to close the question before it is ready to be closed. just the quiet placement of instruments in a dark valley, the careful noting of what appears, the addition of each new observation to a body of work that grows slowly and honestly over time. The woman on the warm asphalt in Phoenix, and the Nuremberg printer with his woodcut, and the radar operator banking his attention toward a screen that showed something his training had not prepared him for, and the police officer watching a large silent triangle cross the Belgian sky at low altitude. They were all in their own ways doing something similar. They were paying careful attention to something that was actually there in the actual sky above an actual city on an actual night. They noted what they saw. Some of them wrote it down. The instruments in the Hestelen Valley are still writing it down, and the lights for now still come. In a field in Qinghai province, on an evening in the summer of 2012, a team of atmospheric researchers was setting up equipment in the open air. The light was going out of the sky. One of the researchers was positioning a spectrometer on a tripod, its lens pointed upward toward the last pale blue of the evening, and another was checking the connections on a video recorder that had been designed to capture lightning during the storms that moved regularly across this high plateau in the warmer months. They had been in the field for several days already. They had captured lightning, and they had captured ordinary things, and they were packing up their notes from the session when something drifted into the upper left corner of the camera's field of view and held there. It was a pale sphere, roughly the size of a grapefruit, and it was giving off its own light, not reflected light, not the scattered light of a lamp or a distant road. It was producing a cool, self-contained glow, and it moved through the air with a slowness that had no obvious cause. No wind was moving it, no visible current was carrying it, nothing appeared to be pushing it along. The spectrometer was still running, the camera was still recording. The sphere drifted through the frame for a few seconds, holding its form, its surface neither flickering violently nor holding perfectly still, and then it simply was not there anymore, having dissipated near the far edge of the image with no sound and no flash. When the research team reviewed the footage and the spectrometer data together, they found something specific in the numbers. The light had left a chemical signature. The spectrometer had recorded the presence of silicon, iron, and calcium, elements entirely consistent with vaporized soil, with the minerals of the ground beneath the field where the researchers were standing. The sphere had contained, in some form, the earth it had apparently risen from. This was the first confirmed instrumental recording of ball lightning, a phenomenon that had been reported by witnesses for centuries and doubted by a portion of the scientific community for almost as long, partly because no one had ever managed to point a calibrated instrument at one and collect the numbers before it disappeared. Ball lightning occupies a specific and honest category in the study of unexplained luminous phenomena. It is not unknown. It is not a thing that has been merely reported and never substantiated. It appears in the scientific literature, it has been assigned a variety of proposed mechanisms, and it has now been recorded on video and analyzed spectrometrically by a research team in the field. What it does not yet have is a single agreed explanation for why it forms, how it maintains its coherence, or precisely what process causes it to hold together as a sphere of light in open air before quietly coming apart. The Qinghai data moved the conversation forward considerably, but the mechanism is still debated, and the conditions under which ball lightning reliably forms are not yet understood well enough to produce one deliberately in a laboratory setting. Reported sizes have ranged from 1 centimeter to several meters across. Most accounts describe something between a golf ball and a basketball. The color varies: pale white, yellow, orange, blue, and the duration varies too, from a few seconds to, in some claimed accounts, several minutes. Some accounts describe a sphere that passes through a window or a wall, which has been proposed as consistent with a form of plasma interacting with a weak electromagnetic field, though this specific behavior remains the most contested detail in the literature. What is not contested is that the Qinghai recording exists, that the spectrometer data from that recording exists, and that the chemical signature in the data is the signature of the ground. Something was lifted, held together, and then let go. The sky does other things with light that produce equally distinctive results, and not all of them involve plasma or electricity. Some of the most structured and remarkable luminous effects in the atmosphere are produced by nothing more energetic than a difference in temperature between two layers of air, sitting one above the other. When a layer of unusually warm air sits directly above a layer of cooler air near the ground, the boundary between them acts as a kind of lens, bending light along curved paths that it would not ordinarily follow. The result, in the right conditions, can be extraordinary. Over calm water or flat land, this bending can make a distant city appear to float above the horizon. Lights that are 50 or 100 miles away can seem to be only a few miles distant and elevated slightly off the ground as though hanging in the air. Ships that should be below the curvature of the earth appear above it, sometimes inverted, sometimes multiplied into stacked columns that bear almost no resemblance to the original vessel. A lighthouse can appear as three lighthouses, one above the other, the lowest one right side up, and the highest one upside down. This category of mirage has a name taken from the Italian operatic character Fata Morgana, Morgan Le Fay, the enchantress who created castles in the air to lure sailors to their ruin, and the name is not inappropriate. The atmosphere, under the right temperature conditions, can construct convincing architecture out of distant light. The Fata Morgana is technically a superior mirage, meaning the false image appears above the actual object rather than below it, which is how the simpler mirage of a desert road appearing wet in the heat works, those being inferior mirages, the image appearing below. The superior version requires a temperature inversion layer, cooler air beneath, warmer air above, and the stronger and more sharply defined that boundary is, the more complex and elaborate the distortions it produces. A clear night over a flat, calm surface is one of the more reliable conditions for strong inversion layers to form, as the ground radiates heat upward and the air nearest it cools faster than the air above. This is why the most dramatic documented cases of Fata Morgana involve harbor pilots, coast watchers, and fishing communities, people who spend long hours over calm water in the dark in conditions almost engineered to produce the phenomenon. What a Fata Morgana does to the lights of a distant city, seen from the right angle through a strong inversion layer, is difficult to predict in detail and impossible to describe in general terms without understating it. The lights may appear to rise, they may appear to multiply vertically, they may appear to pulse or shift as the temperature boundary fluctuates in the light winds. A row of ordinary streetlights on a coastal road 50 miles away might resolve, at a certain distance through a certain inversion layer, into something that looks structurally quite unlike a row of streetlights. The atmospheric optics here are well established, and the calculations behind them are not simple, but they are not mysterious either. They follow from basic physics, from the way the refractive index of air changes with temperature, from the mathematics of curved light paths through layered media. The interesting thing is not that the atmosphere can do this. The interesting thing is the frequency with which these conditions arise quietly, without announcement, over cities and coastlines where people happened to be looking at the sky. A different category of unexplained light in the sky has a geological rather than meteorological origin, and the people who first documented it in detail were not atmospheric physicists but seismologists, and even they took some time to accept what they were seeing. Earthquake lights are exactly what the name describes. They are luminous phenomena, glowing orbs, horizontal streaks, flickering columns, diffuse glows in the sky that appear in connection with significant seismic activity. They do not necessarily appear at the moment of the earthquake itself. They have been reported hours before the ground moves, during the shaking, and days afterward during aftershock sequences. The relationship between the lights and the seismic event is consistent enough and documented across enough independent accounts that the phenomenon is now part of the mainstream seismological literature, though the mechanism that produces the lights is still a matter of active research. The photographs from the 1966 Matsushiro earthquake swarm in Japan are among the clearest early instrumental records. Matsushiro is a town in Nagano Prefecture, and in 1965 and 1966, it experienced an unusually prolonged sequence of small and medium earthquakes, thousands of them over the course of about a year, with the most intense period in the spring and summer of 1966. During that period, residents and researchers working in the area photographed and documented lights in the sky on multiple occasions, including what appear in the photographs as luminous arcs in diffuse bright areas that have no obvious correspondence to any fixed artificial light source. The images were taken by people who were already in the field studying the seismic sequence, which gave them a credibility that pure eyewitness reports sometimes lack. The 2009 L'Aquila earthquake in central Italy added a different dimension to the record. L'Aquila is a city of about 70,000 people, and on the early morning of April 6th, a magnitude 6.3 earthquake struck the region, causing severe damage and significant loss of life. In the hours before the main shock, and during the period of intense aftershocks that followed, thousands of people reported seeing lights in the sky above the mountains surrounding the city. Some of these reports describe horizontal streaks of pale light crossing the sky without sound. Others describe glowing areas that appeared and faded above the ridgelines. The scale of the reporting was sufficient, and the accounts were sufficiently consistent with one another that the lights were noted in technical analyses of the event alongside the seismic data. The proposed mechanism most frequently discussed involves the piezoelectric properties of certain rock types, the way quartz-bearing rock under intense pressure generates electric charge, and the way that charge might interact with air at the surface to produce luminous effects. Though this explanation is still debated and may not account for all of the observed phenomena, what the earthquake lights cases share, from Matsushiro to L'Aquila, and in the other documented instances between and since, is a quality of calm strangeness. The lights are not violent. They do not appear to interact with anything. They hold their position or move slowly, and they fade without drama. Witnesses describe them with the language of observation rather than alarm: a slow streak, a soft glow, a column of light above the ridge, and the descriptions have a consistency across widely separated accounts and widely separated earthquake events that is itself a kind of data. Whatever the mechanism, the sky above a seismically active region can produce light from the ground up, quietly, without anything in the atmosphere itself being responsible. Further up the scale of documented atmospheric electrical phenomena, and considerably better understood at the mechanistic level, is a form of luminous discharge that has been known by name for centuries, recorded in the diaries of sailors, the chronicles of medieval monks, the logbooks of aviators, and the maintenance records of radio tower operators. St. Elmo's fire is not a mystery in the sense that earthquake lights are a mystery, or in the sense that the Qinghai sphere was a mystery until the spectrometer data arrived. The physics behind it is well established. It is a form of plasma discharge produced when the electric field around a pointed or elevated conductor becomes strong enough to ionize the surrounding air. Not a spark, not a flash, but a sustained glow, blue or violet, that holds its position on the conductor and persists for as long as the field conditions maintain it. The practical conditions for St. Elmo's fire are not particularly rare. A tall, pointed conductor during a thunderstorm, the iron cross at the tip of a cathedral spire, the mast of a ship at sea, the radio antenna on a hill above a city, the corner of a skyscraper during a charged weather system can produce the effect reliably if the electrical gradient in the surrounding air is strong enough. What varies is the visibility. In a bright urban environment, the faint blue-violet glow of a plasma discharge on a tower might not be easily noticed. On a dark sea, on a rural hilltop, in the air around an aircraft's wingtip, during a night flight through electrified cloud, it becomes quite visible, a steady, softly pulsing halo of light attached to something man-made and elevated, visible to observers some distance away, on the ground or on the water below. Historical sailors understood it as a sign, and a specific one. One fire on the mast was considered ominous. The presence of a single Elmo implied danger ahead. Two fires, which they sometimes called Castor and Pollux, were considered favorable, a sign of protection. This interpretation was not random superstition without observational grounding. Two fires often appeared as storms passed through, and their appearance could genuinely signal a change in the local electrical field consistent with the storm's withdrawal. The connection between the fire and the weather was real, even if the interpretation built around it was not what a modern atmospheric physicist would construct. The sailors were watching something real, drawing practical conclusions from it, and encoding those conclusions in a form that preserved them across generations. From ships at sea, the phenomenon traveled naturally into the literature of aviation as soon as aviation existed. Early aviators in open cockpits reported a corona of cold fire around the struts and leading edges of their aircraft in certain weather conditions, and as aircraft became larger and more sophisticated, St. Elmo's fire was incorporated into instrument approach briefings and pilot training as a known phenomenon, notable, harmless, occasionally disorienting if encountered for the first time in low visibility, but not a source of danger in itself. Jet aircraft encountering it at altitude can produce a display visible from the ground as a diffuse glow around the engines and wingtips, and under the right atmospheric conditions and at the right angle to an observer on the ground. This is not something that looks like an aircraft. The sustained electric glow of St. Elmo's fire and the brief self-contained sphere of ball lightning share a quality that makes them both relevant to the study of unexplained luminous phenomena in the sky over cities. They are produced naturally by processes involving no source of light other than the sky and the charged atmosphere itself, and they do not always announce themselves as what they are. Ball lightning appears and disappears. St. Elmo's fire holds its position on a structure that might not be visible from the observing distance. Both phenomena involve light that is moving, or light that is attached to something that can move, and both are generated by conditions that arise regularly in the lower atmosphere without any special or unusual event preceding them. There is a further category of atmospheric luminous phenomena that sits at a more speculative position in the literature, less firmly established than St. Elmo's fire, more proposed than confirmed, but discussed in peer-reviewed journals, and by researchers whose work on the better established phenomena gives their proposals some weight. Plasma vortices are rotating masses of ionized gas, and the theoretical framework for their formation in the lower atmosphere under specific electromagnetic conditions is not in principle implausible. The proposed energy sources include geomagnetic fluctuations, interactions between active weather fronts and local topography, and the concentrations of electromagnetic field that can develop around certain geological features. What these vortices would look like to an observer on the ground is difficult to specify precisely, but the proposals suggest something structured enough to have apparent geometry and luminous enough to be clearly visible at night. The interest in plasma vortices as a natural explanation for certain low-altitude aerial sightings comes partly from the difficulty of fitting those sightings into the other available explanations. Ball lightning is relatively small. Fata Morgana operates at a distance and requires specific terrain. Earthquake lights have a geological correlate that should be detectable seismologically. But accounts of structured, glowing, low-altitude phenomena over populated areas that persist for minutes at a time, observed by multiple witnesses with no seismic precursor and no obvious temperature inversion layer, sit in a gap between the established phenomena. The plasma vortex hypothesis is the kind of proposal that a careful researcher makes when the data does not quite fit the existing categories. Not a definitive explanation, but a direction in which the atmospheric physics might go if studied in the right places with the right instruments. The right instruments are, in this field, very important. Much of what is known about the luminous atmosphere comes from the combination of sensitive cameras, spectrometers that can resolve the chemical composition of a light source, magnetometers, and ionization detectors, instruments that can be left running in a promising location and will record whatever the sky does in the hours between midnight and dawn. One of the most persistent and well-documented natural sites for recurring unexplained lights is a valley in central Norway, and the research conducted there over several decades illustrates what systematic instrumental attention to atmospheric luminous phenomena actually produces. The Hessdalen Valley is a narrow glaciated valley in the county of Trøndelag, about 120 kilometers south of Trondheim. The valley floor sits at roughly 500 meters of elevation. The surrounding hills are covered in boreal forest, and the rock beneath the valley includes deposits of sulfur, zinc, copper, and iron, minerals with electromagnetic properties that are, in various proposals, relevant to the origin of what has been seen there. The Hessdalen lights are not a recent discovery, and they are not a legend that was first noticed when someone decided to pay attention to it. The residents of the valley reported recurring unexplained lights, some of them hovering, some of them moving through the valley at various speeds, from at least the early 1980s, and the intensity of the sightings in the period between 1981 and 1984 was such that residents were reporting seeing unusual lights as often as 20 times per week. That frequency brought researchers, a group of Norwegian scientists and technical volunteers, organized a field study called Project Hessdalen in 1983 and 1984, spending weeks in the valley with cameras, radar, magnetometers, and spectrum analyzers, and collecting instrumental data on the lights, rather than depending solely on eyewitness accounts. The project documented 33 observations during its field period, with several of these confirmed on multiple instruments simultaneously. The lights varied in appearance and behavior: white, yellow, or red orbs, some of them moving through the valley at low speed, some of them hovering for extended periods above the valley floor or above the ridge to the east, some of them blinking in regular patterns, some of them steady. The data collected in 1983 and 1984 did not produce a definitive explanation, but it confirmed that the lights were real, in the sense that they registered on instruments that are not susceptible to the perceptual errors that affect human observers looking at a dark sky, radar-detected objects. The spectrum analyzer produced data from the lights it captured. The photographs were consistent with the other instrumental records. This was not a case in which a scientific investigation found nothing. It found something, and the something was genuinely anomalous relative to the known sources of light in the valley. The frequency of sightings has decreased considerably since the most intense period in the early 1980s, but the lights have not stopped entirely. A permanent automated monitoring station was eventually established in the valley, designed to run continuously without requiring human observers to be present. The station includes cameras capable of operating in low-light conditions, spectrum analyzers, magnetometers, and a weather station providing continuous readings of temperature, humidity, and pressure. When a light appears in the valley, the instruments register it, record it, and timestamp it against the meteorological and geomagnetic data from the same interval. The record builds steadily without gaps through the winters and summers of the Norwegian high plateau, and anyone who needs to examine it later can look at what the instruments saw and compare it to the atmospheric conditions at that moment. The current theoretical proposals for the Hessdalen lights include electromagnetic interactions between the conductive mineral deposits in the valley rock and the electrical field of the atmosphere, plasma phenomena sustained by geomagnetic energy, and chemical combustion involving the sulfur deposits in the valley. But none of these proposals, as of the most recent published research, has been confirmed as sufficient to account for all of the observed phenomena. The lights continue to be recorded periodically by the automated station. The question of their origin continues to be studied. What the Hessdalen research demonstrates, and what the ball lightning study in Qinghai demonstrates in a different way, is that the sky does things with electricity and light that are not fully mapped, and that the most productive response to an unexplained luminous phenomenon is to point an instrument at it and let the instrument run. The spectrometer in Qinghai was running when the sphere arrived, and the chemical signature in the data has outlasted the sphere itself by more than a decade. The monitoring station in Hessdalen keeps its instruments pointed at the valley regardless of whether anything is visible on any particular night, because the atmospheric events worth recording do not wait to be scheduled. This quality of patient attention is something the study of natural luminous phenomena requires above most other qualities. The phenomena do not perform on demand. Ball lightning cannot be summoned. Fata Morgana requires the right temperature structure in the right place at the right moment. And earthquake lights are coupled to events in the crust that are themselves imperfectly predicted. St. Elmo's fire appears when the electrical gradient around a conductor crosses a specific threshold and dissipates when it drops below it again. Plasma vortices, if they exist in the form proposed, presumably arise from confluences of electromagnetic conditions that themselves arise from interactions between topography and weather patterns that are not controlled by any observer. The atmospheric events that produce unexplained light are, in almost every case, the kind of events that reward instruments left running unattended through the long hours of a clear or partly cloudy night, rather than the kind of events that announce themselves to a researcher who has arrived expecting something. The monitoring station sits in the Hessdalen Valley, in the Norwegian dark. Its cameras face the valley floor in the eastern ridge. The magnetometer reads the geomagnetic field steadily, ticking its measurements into the record, at whatever interval it has been set to. The temperature is below freezing for much of the year, and the station is designed to operate through that. Snow accumulates on the ridge and compresses in the dark. The boreal forest on the hillsides holds its position silently. Whatever the sky does over the valley on any given night, whether a light appears and hovers, or whether nothing visible occurs at all, the instruments note it, and the record of what the atmosphere has done in this particular place grows longer, line by careful line, through the hours before dawn. The sky above the valley is very dark. The nearest town is several kilometers away, and its lights do not reach the valley floor with any strength. When a hovering light does appear above the eastern ridge and holds its position for several minutes before shifting direction, the cameras track it, and the magnetometer records what the field does at that moment, and the spectrum analyzer, if the light is bright enough, records the wavelengths of what the light is made of. Sometimes the light is bright enough, sometimes it is not. The instruments record both outcomes with the same even attention. There are other valleys, other monitoring programs, other instruments running through other dark nights in other parts of the world where the atmosphere has shown a disposition to produce light that is not easily attributed to known sources. The study of these places is slow, methodical work, and its conclusions arrive gradually as years of instrumental data accumulate into a record long enough to distinguish a pattern from a coincidence. The researchers who do this work are not, for the most part, in the habit of announcing conclusions before the data supports them. They note what the instruments record. They compare it to what is already known about atmospheric electricity and plasma physics and geochemistry, and they write papers that say what the data permits them to say, and no more. The atmosphere is not a simple medium. It is a layered, charged, chemically complex system that extends from the ground to the edge of space and interacts continuously with the magnetic field of the Earth, the heat of the sun, the electrical activity of weather, and the geological and mineral properties of the terrain beneath it. That this system occasionally produces light that observers on the ground do not recognize as any familiar thing is, when considered at that scale, not surprising. What is perhaps more interesting is the specific forms that light takes: the pale hovering sphere, the slow streak above the mountains, the steady violet glow on the iron tip of a church spire, and the consistency with which human observers across different countries and different centuries have watched these forms with the same careful attention and reached for language to describe what they have seen. Somewhere in a sleeping town, the rain that has been falling since midnight is beginning to ease. The clouds are still low and moving. High on the hill above the town, a church stands in the dark, its spire rising above the roofline of the surrounding houses, the iron cross at its peak pointing into the charged and damp air. As the last of the active weather system passes through, as the electrical gradient in the air around the cross reaches the threshold at which the surrounding air will carry a current, a soft glow appears at the very tip of the iron. It is blue. It has a slight violet quality at its edges. It pulses gently, not in any mechanical rhythm, but in the rhythm of the fluctuating field that sustains it, a rhythm that comes from the atmosphere and goes where the atmosphere takes it. The glow holds its position on the cross.
Neither spreading nor shrinking, illuminating nothing below it but itself. A steady cold light above the wet rooftops and the empty street, burning as long as the conditions hold, resting there above the town with the quiet, patient quality of a thing that is neither announcing itself nor trying to be seen, simply present, lit from within by the particular physics of a charged night, slowly fading as the weather moves on and the field drops back below the threshold until the cross is dark again.
And the rain has stopped, and the street below is perfectly still. An F-94 Starfire moves through the dark above Washington, D.C., at roughly 500 miles an hour, its pilot scanning the air ahead with the particular kind of attention that is neither tense nor relaxed, but simply open, the trained, waiting readiness of someone who knows the instrument panel by feel and so can spend his eyes on the dark outside the glass. The return had been there on the radar at Andrews. The controllers had called it in. The jet had climbed and banked and found the correct heading, and now the air ahead is empty, and the return is gone, and the pilot holds his course for another 30 seconds before the radio crackles with a new bearing and a new heading, and the information that the object has reappeared somewhere else entirely. It is July of 1952. This has happened before tonight, and it will happen again before the night is over. What the Air Force was doing in that cockpit is in one sense very simple. Something appeared in the airspace above the Capitol. The Air Force sent someone to look at it. That sequence, a light appears. An institution responds. People in positions of responsibility move toward the thing and try to determine what it is. Turns out to be a very old pattern and one that has repeated itself in various forms and with various tools across more than a century of documented encounters between cities and their unexplained skies. The pilot at the controls of the Starfire that night was not performing a symbolic act. He was doing a job, a specific and procedurally defined job, with clear objectives and a clear reporting structure. The object had appeared on radar. Radar in 1952 was still a relatively recent technology with known limitations and known strengths, and the controllers at Washington National and at Andrews had been reading it carefully and comparing their returns and confirming with each other that what they were seeing was not a weather ghost or a calibration artifact. The returns tracked, they moved, they changed direction in ways that the traffic expected in that corridor did not change direction, and so the call went up and the fighters went up after it, and for a period of time on 2 separate nights, in July of 1952, there were United States military aircraft trying to close the distance between themselves and something that kept opening that distance faster than they could close it. What the pilots reported afterward was not dramatic. The objects accelerated. They changed bearing. On at least one occasion, a pilot reported seeing a light ahead of him that simply was no longer there when he reached the position where it had been. The language in the debrief reports, which were later reviewed as part of the Air Force's formal investigation, is the language of trained observers doing their best with an event that did not conform to the categories they had for it. Not frightened language, not certain language, careful language. The 2 nights in Washington prompted what is still described in the historical record of military public affairs as the largest Pentagon press conference held since the end of the Second World War. General John Samford stood before the assembled press and spoke for some time about the sightings, acknowledging that they were real, that some of them came from credible sources, and that no firm explanation had been established. The press conference itself is interesting as an object. It is a large institution standing in front of cameras and saying something happened. We do not know what it was, and we are telling you this in public. That is a particular kind of response to unexplained aerial phenomena, and it is not the only kind, but it is one worth holding in mind. The institution showed up. It spoke out loud. It said the thing was real, and the explanation was missing. The Air Force had been developing its formal approach to unexplained aerial reports for several years before the Washington incidents. Project Sign had been established in 1947. The same year, a private pilot named Kenneth Arnold reported seeing a formation of objects near Mount Rainier and described their movement in terms that led the press to coin the phrase, flying saucers. a phrase Arnold himself had not used. Sign gave way to Project Grudge and then to Project Blue Book, which operated from 1952 to 1969 and became the most extensive and most carefully documented government effort to systematically examine what people were reporting when they reported something unexplained in the sky. Over those 17 years, the project accumulated 12,618 individual case files. Each file represented a reported sighting. Each was reviewed, cross-referenced against weather data and known air traffic and astronomical events, and assigned a classification. Most were explained. A significant number were not. When the project concluded in 1969, 701 of those 12,618 cases remained formally classified as unidentified. Not hoaxes, not misidentifications that had simply been missed, genuinely unresolved, even after thorough analysis by people whose professional obligation was to find the mundane explanation, if one existed. Those 701 cases are not a small number. They are not a residue so minor that it can be comfortably ignored. A researcher sitting with the Blue Book files today, and many have, encounters in those unresolved cases the same basic situation the Starfire pilot encountered in the air above Washington, a trained observer, the documented event, and the honest notation that what the documentation describes does not match what the available explanations can account for. The files do not prove anything beyond their own incompleteness. What they establish is that the question was taken seriously, and that taking it seriously did not make it go away. In 1997, the city of Phoenix encountered something that did not fit the categories available to it, and the city's response unfolded in real time across its emergency and media infrastructure. The Phoenix Police Department received hundreds of calls in a window of time so compressed that the dispatchers were effectively handling a simultaneous event rather than a sequence of individual reports. Each call was a resident reporting something moving over the city, a row of lights, slow, silent, very large in apparent size, heading southeast. The calls came from different neighborhoods. The callers were describing what they were seeing from different vantage points in different elevations, from yards and rooftops and the sides of roads, and the thing they were describing was consistent across all of them in the ways that mattered: the lights, the silence, the speed, the direction. A police dispatcher working a busy night does not generally have the capacity to compare one caller's report to another in real time. The calls are logged, the appropriate units are notified, and the dispatcher moves to the next call. On the night of March 13, 1997, the Phoenix Police Department's intake process was handling the kind of volume that turns a methodical system into something more improvised, keeping the information moving, noting what could be noted, not having time to step back and see what the whole picture looked like. The picture, when someone did step back and look at it, was of a citywide event observed simultaneously by hundreds of people who had not consulted one another and were not coordinating their reports. The local television and radio stations received calls at the same rate. Newsrooms that were staffed for an ordinary Thursday evening found themselves with more incoming information than their normal intake structures could process. Some stations began putting callers on hold. Some took names and numbers and called back later. A few managed to get cameras outside and pointed at the sky in time to record something, though the footage that came back was the footage that low-light cameras pointed at a dark sky tend to produce: bright points against black, ambiguous in shape and context, in some ways more puzzling than the verbal accounts, because the cameras could not capture the scale and the silence that the witnesses kept returning to when they described what they had seen. The silence mattered to people. It came up again and again in the accounts gathered afterward. The object, or the formation, depending on how the lights were interpreted, was large. Witnesses who were experienced with aircraft, who lived near enough to Sky Harbor International Airport to know what commercial jets looked like and sounded like at various distances and altitudes, reported that the thing above them was not making the sound that something that size should have been making. Several witnesses used the phrase dead silent. The absence of sound was in some ways more striking to them than the presence of lights, because lights in the sky at night are not inherently anomalous, but something very large and very close that produces no sound at all is anomalous in a way that is immediately felt, rather than reasoned toward. The Arizona Air National Guard was eventually asked about the night of March 13th, and the official response, which came some time after the event, was that flares had been dropped during a training exercise in the area south of Phoenix. The timing and the geography of the flare exercise were consistent with some of what had been reported. They were not consistent with all of it. There were accounts from earlier in the evening, from the northern part of the state, describing a large formation of lights traveling at low altitude over populated areas, and those accounts were not addressed by the flare explanation. The two things may have been separate events on the same night. What the flare explanation did was provide an official accounting for at least some of what had been reported, and it did so in procedural, institutional language, a training exercise, a known schedule, a documented activity, which is what official explanations characteristically sound like, whether or not they fully resolve the question. The 1896 and 1897 airship wave preceded all of this institutional apparatus by several decades. There were no jet fighters to scramble, no Pentagon press conferences, no formal investigation offices with filing systems and classification protocols. What there was across the Midwest and the Pacific states of the United States over a period of several months was a series of sightings reported by large numbers of people in dozens of separate towns and cities, and the institution that captured and preserved that record was the newspaper. The American newspaper in 1897 was a genuinely local enterprise. Most towns of any size had at least one, and the accounts of what residents were seeing in the night sky found their way into print because local papers printed what local people were talking about. And in the winter and spring of 1896 and 1897, what local people were talking about was the large cigar-shaped object with bright lights that various witnesses had reported seeing over their town. The accounts are not consistent with each other in the ways that would satisfy a rigorous investigator. They vary in the details of what the object looked like, how fast it was moving, how loud it was, what color its lights were. Some accounts include conversations the witness claims to have had with the occupants, which puts those accounts in a different category from the simple visual reports. Some accounts were clearly the work of journalists, who understood that extraordinary reports sold papers and were not excessively constrained by their obligations to accuracy. What the newspaper archive of the 1896-97 wave preserves, even after accounting for all of that, is something that no later reconstruction could have produced, a real-time record of how a large number of ordinary people across a wide geographic area processed and reported an unusual shared experience. The papers printed letters from readers. They printed statements from local officials. They printed accounts from train conductors and night watchmen and ministers and farmers, people in professions that required them to be outside at night, looking at things, paying attention to the sky. The picture that comes out of all of that is not a clear picture of what those people actually saw. It is, instead, a clear picture of a society in the process of encountering something it did not have a settled framework for, and doing what societies do in those moments, talking, writing, arguing, proposing explanations, revising them, and adding detail. The sociologist Robert Bartholomew spent considerable time with the historical record of mass sighting events and noted something about the relationship between media coverage and the shape of what gets reported. When the first accounts of an aerial event appear in print or on radio or television, the people who witnessed the event but had not yet reported it encounter those accounts, and in the process, their own memories and interpretations of what they saw are shaped by the framing the coverage provides. Someone who saw a light in the sky and was uncertain what it was may, after seeing a news report describing a V-shaped formation of lights, remember the light they saw as part of a V-shape. Someone who was unsure of the color of a light they observed may find that the color given in media reports feels correct in retrospect and adopt it as part of their own account. This is not dishonesty. It is how memory works under conditions of uncertainty, and it means that the record of any mass sighting event is in part a record of the reporting process itself. What Bartholomew's observation does not mean is that the events did not happen. It means the events, as they are preserved in the record, are composites, original observations gathered up and reshaped by the process of collective attention. The expanded, mediated account of a sighting is real in its own terms, as a social and cultural event, even when it has grown beyond what any individual witness can confirm from direct observation. Both things can be true at once. Something was seen, and the record of what was seen is larger and more complex than what was seen, because the act of reporting transformed it. The Belgian Air Force's engagement with the sightings that occurred over the country, beginning in November of 1989, took a form that was unusual in the history of institutional responses to unexplained aerial events. The reports had been coming in from civilian witnesses and from members of the Belgian police since the end of November, and the volume and consistency of the reports was sufficient to prompt the Belgian Air Force to treat the matter as something requiring a formal, acknowledged response rather than a quiet internal review. Colonel Wilfried de Brouwer, who served as head of operations for the Belgian Air Staff, eventually held a press conference at which he stated plainly that the triangular objects reported by witnesses across the country, by thousands of civilians, and by police officers who had observed them from their vehicles on the ground, were real events, were not attributable to any aircraft in the Belgian Air Force's inventory, or, to the best of his knowledge, any aircraft belonging to any allied nation, and remained, as of the date of the press conference, unexplained. De Brouwer was not a marginal figure speaking outside his authority. He was a senior military officer speaking in an official capacity about an official investigation, and what he was saying was that the investigation had not produced an explanation. The Belgian Air Force subsequently scrambled F-16 fighters on at least one occasion to investigate radar returns consistent with the reports, and those fighters did not make contact with any object. The radar returns they tracked showed accelerations that would have been extraordinary for any conventional aircraft. The investigation continued. The explanation did not arrive. What is notable about the Belgian case is that the institutional response, open, public, honest about its limits, did not resolve the public interest in the sightings, but it did shape the character of that interest. There was no sustained accusation that the government was hiding something, no persistent counter-narrative built around the idea of deliberate concealment, at least not in the terms that characterized other national responses to unexplained aerial events. The Air Force had said it did not know. That acknowledgement did not close the question, but it gave people a framework, Not a satisfying one, not a complete one, but an honest one for where the official account stood. Project Blue Book's closure in 1969 did not end the American government's engagement with unexplained aerial phenomena. It interrupted it in an official public sense. There was no longer a named project, no longer a formal filing structure, no longer a public-facing process. The question went on being reported, went on being observed, went on finding its way into the testimony of pilots and air traffic controllers and military personnel who had seen things in the sky that they could not account for with the categories available to them. Decades later, in 2022, the United States Department of Defense established the All-Domain Anomaly Resolution Office, which is a more recent institutional acknowledgement that the category of unexplained aerial phenomena has not emptied itself out, and that systematic attention to it, using modern sensor technology and a formal analytical structure, is a reasonable ongoing commitment. The name is different from Blue Book's name. The mandate is somewhat different. The basic orientation is the same. Something is being reported by credible observers. It is not being explained by available information, and the appropriate response is careful, documented, continued attention. The gap between Blue Book's closure and the establishment of its successor spans more than 50 years, and the reports continued across that gap, documented in congressional testimony, in the accounts of military pilots who described encounters with objects that could outperform any aircraft they knew of, in radar records and infrared sensor footage that was eventually released to the public. The institutional response during those decades was inconsistent, sometimes dismissive, sometimes attentive, sometimes confined to quiet internal analysis that never reached official public acknowledgement. What the 2022 establishment of the new office represents is a return to a position the Air Force had occupied at its most transparent moments, the position that says the unexplained things deserve a structure, a process, a place in the institutional record, even when that record can offer no definitive conclusion. There is a specific kind of attention that institutions bring to unexplained events that differs from the attention individual witnesses bring. A witness standing in a field or on a rooftop or at the wheel of a police cruiser at night, watching something move above them, brings the whole of their perception to the moment, the sound of the air, the temperature, the feeling of looking up, the way the light behaves against the dark. An institution brings a different apparatus, radar data, flight logs, atmospheric records, formal interviews, cross-referenced reports from multiple locations. Neither kind of attention is complete on its own. The witness captures what the radar cannot, the sensation, the quality, the physical reality of standing under the thing and looking up at it. The institution captures what the witness cannot hold at once, the scale of the event across geography and time, the comparison to other events, the systematic elimination of known explanations. Those two forms of attention are not competitors. They are pieces of the same effort to understand what happened, and they have been working alongside each other in various combinations of coordination and disconnect since at least the summer of 1952, when the Starfire pilots were climbing toward returns that kept moving away from them above the warm-lit city. On that night in Washington, the press conference that followed the sightings was itself a kind of document, a record not just of what was said, but of the institutional position that it was appropriate to say it publicly, to bring the reporters in, to stand at the podium and say this happened, and we are working on it, and we do not have the answer yet. General Samford's statement was careful in the way that official statements at that level tend to be careful. It did not overclaim. It did not dismiss. It held the middle position that the evidence required. Real events, credible sources, no established explanation. The reporter sitting in that press conference room in 1952, writing in a notebook, was doing what the newspaper typesetter in 1897 was doing when he set the type to describe the illuminated airship over the town square, which was itself not entirely different from what the Project Blue Book analyst was doing in the early 1960s when he opened the next folder in the stack and read the next witness statement and made his notation in the unidentified column. Each of them was doing the work of recording that something had been seen and that the seeing had not yet been resolved into a satisfying explanation. Each of them was adding to a record that is, when considered across its full span, a very long and very serious engagement with a question that keeps presenting itself over cities and across skies, and in the testimony of people who have no particular reason to report things that did not happen. Somewhere in Texas, on a street in a residential neighborhood, late in the evening, a cluster of neighbors stands in the road, looking up at something above the tree line. Two of them have their phones out. One is dialing the local television station's news tip line. Another is already on hold. The rest are watching the thing move, not fast, not erratic, just steady and slow and silent, and none of them has picked a category for it yet. One of them says the word plane and then doesn't say anything else because the word doesn't quite fit what's there. The person on hold listens to the hold music and watches the thing and tries to find the words that will, when the line picks up, be adequate to what they are currently looking at. The tree line is dark. The sky above it is not quite as dark. The thing moves through that difference between the two darks and goes on moving, and the neighbors watch it go, and one by one they lower their eyes as it passes out of sight above the rooftops. They will talk about it later, that night and in the days after. The telling will expand. Each conversation will add something, a detail recovered from the moment of watching, a comparison to something else, a question about the altitude or the spacing of the lights. Someone will look it up and find that other people in other parts of the state reported something on the same night, and the knowledge that other people saw it will change the quality of the memory, will give it the solidity that comes from confirmation. The telling will become something larger than the original seeing, not because anyone is exaggerating, but because that is what happens when human attention gathers around an experience that was genuinely shared and genuinely strange, and begins the long, imperfect work of making it into a story that can be held and passed along. Robert Bartholomew's observation was, at its most simple, a description of this process. The reporting makes the event larger. The act of paying collective attention to something transforms the something being attended to. This is not a flaw in the record. It is a feature of how communities process experience together. The way shared attention grows, the way it spreads from person to person, like a signal passing through a network, each node adding something to what it passes on. A light appears over a city on 3 nights in a row. The first person who sees it tells a neighbor. The neighbor tells a coworker. The coworker calls the newspaper. The newspaper prints a story. The story reaches the person across town who also saw the light and hadn't mentioned it to anyone, and now they call the paper with their own account, which adds to the story, which reaches more people, which generates more calls. The event that was, at the moment of its occurrence, a light moving through a dark sky, becomes, in the process of being reported, a shared social fact, something that the community knows about, that the community holds in common, that becomes part of the community's sense of itself and its history. That process is very old. It has been happening in every form that record keeping allows, from the oral accounts passed between neighbors to the Babylonian administrative correspondences sent to kings, from the printed broadsheets of the 16th century to the radio call-in programs of the 20th, from the Blue Book case files to the footage that appears on news broadcasts and is watched by millions of people who are nowhere near the event they are watching. Every one of those forms of record is also a form of attention. Every one of them says, "This happened, it was seen, it deserves to be noted down." The Starfire pilot banked over the lights of the Capitol and found nothing where the return had been, and held his course for another long moment in the quiet of the cockpit before the radio brought him a new bearing. The dispatcher in Phoenix logged the call and picked up the next one. The Blue Book analyst opened the next folder. The Belgian colonel stood at the podium and said what the evidence allowed him to say, which was that the thing was real and the explanation had not arrived. The neighbors in Texas watched the thing move above the tree line and began, while they were still watching it, to try to find the words. What all of them were doing was the same thing, finally, at the level that matters most about it. They were paying careful, honest attention to something that had not explained itself, and they were doing so not in isolation, but in the company of other people who were paying the same attention. Human attention itself, when it gathers around a genuine uncertainty, does something that the uncertainty alone cannot do. It grows. It spreads across a neighborhood, across a city, across the years and the decades of a carefully kept record. It becomes the thing that connects the dispatcher in Phoenix to the Babylonian scribe in Nineveh, the Belgian police officer in his field outside Liège, to the neighbors on their street in Texas. All of them looked up at something they could not name. All of them turned to the person beside them, or the institution behind them, or the record-keeping structure available to them, and said, "I saw this. It was here. It matters that it happened." That quiet persistence, the ongoing act of noting down that something was seen, of adding the account to the record, of saying the question is still open and the attention has not wavered, is itself a kind of light. It does not illuminate the source of what was seen above the city. It does not collapse the uncertainty into a clean answer. What it does is hold the question in a steady human light and pass it forward and keep it warm so that the next person who looks up and sees something they cannot name will find, when they begin to speak about it, that the shape of what they are doing was already familiar, that the record was already waiting, that they are not the first to stand in the dark beneath an inexplicable light, and decide that the right thing to do was to pay close attention and tell someone what they saw. In a room where all the light has been removed, a single point of light appears on the wall ahead. Nothing else is visible, no ceiling, no floor, no edges, no depth, just the light and the dark around it. The participant in Muzaffar Sharif's 1935 experiment sits alone, watching the point hold still, and then, without any warning, without any reason, it begins to move. It drifts to the left, slowly, steadily, the way a leaf moves on water when there is no wind to explain it. The participant watches it go. The drift continues for a moment, then reverses, and the point of light wanders back toward where it started, then climbs a little, then settles. The whole time, nothing in the room has changed. Nothing is touching the light. Nothing is making it move. The light is entirely stationary. The movement is happening somewhere else altogether, in the quiet, involuntary machinery of the mind that is watching it. Sharif was not studying sight. He was studying the way human perception behaves when it is given nothing to lean on. What he found was that when the eye has no reference, No corner, no edge, no horizon, no fixed object to triangulate from. It cannot keep still. It invents motion. The autokinetic effect, as it came to be known, is not an error in the usual sense. It is the visual system doing what it does, which is interpret. Without a framework to interpret against, it interprets on its own, and what it produces is movement where there is none. The implications of this are worth sitting with for a moment. A single lamp in a dark field, a lit window at the edge of a tree line, a planet near the horizon on a clear night, any isolated point of light seen against a featureless dark ground will, to some degree, appear to move, not because the observer is unreliable, and not because the light is doing anything, simply because the eye, floating in darkness, needs something to press against, and when there is nothing, it drifts on its own. Sheriff found that participants in the study became genuinely confident in the movement they reported, because the movement felt entirely real to them. It was real in every way, except that it was not happening outside their bodies. What the study suggested, and what the decades of research that followed it confirmed, is that the night sky is one of the most difficult environments in which a human eye is ever asked to work. It is, in many ways, a perfect condition for producing exactly the effect Sheriff documented in his darkened room. Wide dark, scattered lights, no horizon close enough to anchor against, and an observer whose eyes are making thousands of tiny adjustments per second in an attempt to hold focus against a background that offers almost no grip. Whatever the observer reports about what the lights are doing, it is worth knowing that the eye was working very hard to see them at all, and that some of what it reported as motion may have been its own effort. This does not mean the lights were not there. It means the account of what they did is more complicated than it might appear, and that the complication is not a flaw in the observer. It is simply what the human visual system does at night, in the dark, without a fence post to hold still against. There is another process at work in the night sky, and it operates at a slightly different level. When there is not a single light to watch, but several, when a person looks up and finds 5 or 7 or 12 scattered points distributed across the dark, something happens that is worth understanding on its own terms. The mind, encountering a collection of separate elements, does not see them as separate. It groups them. It reaches automatically and without any deliberate effort for the pattern that connects them. This is pareidolia, though the word is almost always used for the version in which a face appears in a pattern of shadows or a cloud arranges itself into something recognizable. The sky version works by the same mechanism, and it is worth noting that it works in multiple directions at once. Different observers, looking at the same scattered collection of lights, will group them differently. One person will see a V shape, another will see an arc, a third will describe a rough triangle, a fourth might say the lights were arranged in a straight line. None of them are wrong about what they saw, in the sense that the visual system genuinely organized the lights that way for them. The organization happened. What is less clear is whether the organization existed outside the mind, doing the organizing. Research on this effect has found that the groupings are not random. Certain configurations are more likely to be perceived by certain observers, depending on how the lights are spaced, what colors they are, and how long the observer watches. But it is also found that different witnesses at the same event can produce accounts of the formation's shape that differ not in minor detail, but in basic geometry. If one witness reports a V, and another reports a triangle, and a third reports an arc, and all three were standing within a few hundred meters of one another, the most likely explanation involves this process, the automatic, involuntary organization of scattered lights into coherent shapes, rather than any difference in what was physically above them. The city sky adds further complications to this. The lights of buildings, towers, moving vehicles, and lit windows provide a constant background against which any aerial lights must be seen. The brain strips the familiar background away and attends to the unfamiliar foreground, and in doing so, it is making thousands of small editorial decisions about what belongs together. Several lights that appear to move in formation may be doing exactly that, or they may be entirely unrelated lights, some moving and some fixed, that the eye has assembled into a group because they were in the same general part of the visual field at the same moment. None of this should suggest that the observers were confused or unreliable in any simple sense. The process of grouping scattered elements into patterns is not a malfunction. It is one of the most important things visual perception does. It is what allows a person to read text, recognize a face in changing light, or find a familiar shape in a cluttered room. At night, over a city, with unfamiliar lights in unusual positions, the same process runs exactly as it was built to run, and what it produces is a formation where there may or may not have been one. Among the many things that change the way a person sees the sky, the condition of having been awake for a very long time is one of the most consistent and the most documented. Research conducted at the Walter Reed Army Institute of Research established, across a series of studies with healthy adult participants, that the visual system begins to behave in noticeably different ways after approximately 24 hours without sleep. This is not a dramatic threshold or a sudden collapse. It is a gradual process that begins well before the 24-hour mark and continues to develop as wakefulness extends. What the research documented in specific and repeatable detail is that sleep-deprived participants begin to experience spontaneous visual distortions, not hallucinations in the clinical sense, but subtle alterations in the behavior of what they see. Stationary objects appear to shift. A line on a wall seems to breathe. A ceiling tile seems to bow slightly inward and then return. Moving objects leave trails behind them, brief luminous smears that persist for a fraction of a second after the object has gone. The changes are small, not dramatic, but they are consistent across participants, and they are not reported by participants who are adequately rested. In the context of night sky observations, this is worth considering. The lights that appear most often in documented sighting accounts tend to appear in the late evening or the early hours of the morning, the hours when many people are already tired, when vigilance is lower and the body is preparing for sleep, and when a person who has been standing outside watching the sky for 20 or 30 minutes is dealing with the accumulated fatigue of a day. The eye watching an uncertain light in those conditions is not the same as the eye that watched the same light 2 hours earlier. The involuntary distortions documented in controlled sleep research conditions apply, in varying degree, to that fatigue as well. The effect on reported brightness is worth noting separately. Tired eyes operating in low light tend to amplify sources of light, not because the light has changed, but because the visual system's calibration drifts under fatigue in ways that make weak sources appear brighter than they are. A light that a rested observer would note as dim and distant will sometimes be reported by an observer who is tired as brighter, closer, and larger. This is not imagination. The neurological mechanisms involved are reasonably well understood. The eye is not lying. It is reporting honestly what it perceives, and what it perceives has shifted in a direction that makes uncertain lights appear more certain and more present than they may be. The point, again, is not that the observers in these cases were unreliable. It is that perception is not a passive record. It is an active process shaped by the conditions under which it operates, and those conditions include how long the observer has been awake, what the ambient light levels are, what background references are available, and a dozen other factors that change from moment to moment and observer to observer. The lights people report seeing in the dark sky are real to them in the most direct sense. What the research asks is a quieter and more specific question: whether the account of what the lights did, how large they were, how bright, how far away, exactly what shape, whether all of that can be taken as a direct and unmediated record of something external, or whether some portion of it belongs to the eye and the mind that we're watching. There is a process that operates not in the moment of seeing, but afterward, and it may be the most underappreciated of all the factors that shape what a person reports about an event in the sky. The psychologist Elizabeth Loftus spent much of her career establishing, through careful experimental work, that memory is not a static record. It is a living thing, rebuilt slightly every time it is accessed, and it is susceptible, in well-documented and replicable ways, to information that enters after the original event. The mechanism she studied, called the misinformation effect, works like this. A person witnesses an event, any event, not only an aerial sighting, but anything that is seen and later remembered. Afterward, in conversation, in a news report, in the questions asked by an investigator or a curious friend, new information arrives. Some of this information is consistent with what the person saw. Some of it differs slightly. Some of it implies something specific about what the event was, or what it looked like. And the memory, each time it is recalled, incorporates some of the new information into itself. The person does not know this is happening. The memory feels to them exactly as clear and intact as it always did, but its contents have changed. Loftus established this through experiments in which participants watched film footage of events and were later asked questions about what they saw. Questions that contained misleading implications that referred to objects that were not present in the film, or that described something in a way that was subtly different from what had appeared, reliably altered what participants later reported. When asked leading questions, participants recalled things that were not there, and recalled them with the same confidence they brought to things that were. The misinformation was not added as a correction or a modification. It was absorbed into the memory as though it had been part of the original experience. For the account of a person who saw something in the sky, the implications are quiet but significant. The first conversation a person has after the event will shape what they remember. The questions an investigator asks will shape it further. The account they read in a newspaper the next morning, or hear on local radio, or see described on a screen will continue to shape it. If those accounts emphasize a particular color, red, amber, white, the observer's memory of the color they saw will move, without their awareness, toward the color that has been emphasized. If the account suggests the object moved in a particular direction, that direction will become easier to access in the observer's own memory of what they saw. This does not mean eyewitness accounts of aerial events are useless. It means they carry within them the traces of all the accounts that followed them, and the effort of separating what was seen from what was later incorporated is genuine and careful work. The clearest and most useful accounts researchers have found are those collected very quickly after the event, before the witness has had much exposure to other descriptions. An account given an hour after the event tends to be quite different from an account given 2 weeks later, and the differences are not always in the direction of greater clarity. There is a particular kind of perceptual error that belongs specifically to the task of judging lights in the dark sky, and it sits at the intersection of distance, altitude, and the way the visual system estimates both. Research in aviation psychology, accumulated over decades of incident investigation and controlled study, has documented a consistent and systematic bias in the way isolated light sources are perceived at night. The bias is in one direction. People reliably underestimate both the distance and the altitude of lights they see at night, particularly when those lights are isolated, when there is nothing nearby to measure them against. The physics of why this happens are well established. In daylight, the eye uses a large number of cues to estimate distance, perspective, the size of familiar objects, the way contrast diminishes with distance, the way detail becomes less distinct in the far field. At night, most of these cues disappear. What remains is brightness, color, and the relative positions of a small number of light sources. From brightness and color alone, the eye attempts to reconstruct distance, and it does this with a systematic error built in. Bright lights at high altitude appear, to the unassisted eye, to be dim lights at low altitude. A lamp on a very tall tower 3 miles away can appear, in the dark, to be hovering just above the nearest rooftop. The error is not a sign of poor vision, it is a predictable product of the conditions. Aviation incident reports are full of cases in which experienced pilots, people trained specifically in the task of navigating by reference to lights at night, misjudged the distance or altitude of light sources in ways that led to near misses, unnecessary course corrections, or failed intercepts. The errors are not failures of attention or ability. They are the result of a genuine limitation in the information available. At night, the visual system works with less data than it does in daylight, and some of what it produces in that condition is necessarily inference rather than observation. For a person standing on a city street, or in a field at the edge of a suburb, or in the parking lot of a closed supermarket, watching a light move in the sky at night, this means something practical. The light they report as hovering just above the telephone lines may be at an altitude of several hundred meters. The light they describe as moving slowly just overhead may be traveling at considerable speed from a considerable height. The light they say was enormous, filling a significant portion of the sky, may be considerably smaller than it appeared, viewed from below without any neighboring reference to measure against. The eye is doing its best with the information it has. What it is able to produce from that information is a genuine perception, held with genuine confidence, that may differ considerably from what measurement would record. A commercial airline pilot descending toward a runway on a dark night once described watching a light in the distance that he judged to be at roughly the same altitude as his aircraft. It held its position steadily while he descended, which told him it was stationary rather than moving. He watched it for several minutes, adjusting his mental model of where it sat and what it might be. Another aircraft on approach, perhaps, holding at a different altitude, or a lit building on a distant ridge. The light did not move, his altitude changed. At the moment he touched down, and the runway light swept past, he looked back at the light and found it precisely where it had been, because it was the top of a radio tower set firmly in the ground 12 miles from the airport, its red warning lamp doing exactly what it had been doing all along. He had judged it to be at his altitude. It was at elevation 0 relative to him. The gap between those two positions was not a small one. The error did not feel like an error while it was being made. This is the distinguishing quality of perceptual mistakes. They do not announce themselves. They feel like ordinary seeing because they are ordinary seeing. The process that produced the wrong altitude judgment is the same process that correctly identifies the runway, reads the instrument panel, and keeps the aircraft on the correct approach path. It is not broken. It is working exactly as it should, with the information available under the conditions that apply. The question that the sleep researcher and the perceptual psychologist and the aviation investigator all approach from different directions is the same question. What portion of the account is the world, and what portion is the mind observing the world? The answer in every case is that the two cannot be completely separated. The world is always seen through a visual system that has its own properties, its own tendencies, its own consistent patterns of error and inference and involuntary invention. This is not a reason for despair about the possibility of knowing anything. It is simply a description of what seeing is. What makes the observation of unexplained nightlights particularly interesting, in light of all this, is that the conditions in which such lights are most often reported are also the conditions in which the visual system is most dependent on its own inference, most likely to produce apparent motion from stationary sources, most susceptible to the grouping of unrelated lights into coherent formations, and most liable to underestimate the distance and altitude of what it sees. Dark sky, isolated sources, no reference framework, often late at night, with an observer who may be tired and who will shortly be exposed to other accounts that will begin reshaping what they remember. None of this explains away the lights. The events recorded over various cities and valleys and plains over many centuries include accounts from multiple independent observers who were not in communication with one another, who described the same configuration from different angles at the same time, and whose accounts were collected before significant media saturation could have homogenized their descriptions. Those accounts carry a kind of evidential weight that the perceptual findings cannot simply dissolve. What the perceptual findings do is complicate the details, the exact shape, the exact speed, the exact altitude, the exact color, in ways that matter for any attempt to characterize what was actually seen with precision. There is a version of this that might feel at this hour slightly melancholy. The idea that the eye cannot be trusted, that memory is porous, that fatigue rewrites what the tired watcher believes they saw. But that is not quite the right way to hold it. The autokinetic effect, the grouping of scattered lights, the way memory absorbs the accounts that follow it, the systematic distance error under dark conditions, none of these are failures. They are all, in one way or another, the visual system and the mind doing what they do, which is make sense of a world that does not always provide enough information to be interpreted with certainty. The eye invents motion because it is built to track motion. The mind groups scattered lights because it is built to find patterns. Memory incorporates new information because it is built to update itself. The distance error exists because under most conditions, the heuristic it embodies is more useful than harmful. What emerges when all of this is held together in a single picture is not a story of unreliable witnesses, but a story of minds and eyes doing an extremely difficult job in extremely difficult conditions and producing results that are genuine and felt and honestly reported, while also being, in certain specific and predictable ways, shaped by the machinery that produced them. The person who stood in the street and watched something they could not explain did watch something they could not explain. What they watched and exactly what it did is a question that perception alone cannot answer with complete confidence, and the part that cannot be answered is not a failure of the observer. It is simply the gap that exists in any observation of any difficult thing between the world and the mind watching it. Muzaffar Sharif, working in his darkened room in 1935, was not trying to catch anyone out. He was trying to understand what happens when perception is given genuinely ambiguous conditions to work with, and what he found was that it works, it continues, it produces results, it provides the observer with a coherent experience, but that the results include contributions from the observer that cannot be removed from the finished picture. The light on the wall was still, and the mind made it move. The mind was not wrong to do so. It was doing what it was made to do, in a room that offered it nothing else. On a dark night, with the city spread below and the sky wide above, and a row of lights crossing steadily from one edge of the horizon to the other, the same processes are at work. The eye is doing what it always does, pressing outward into the available dark, looking for the shapes of things, grouping what it finds, estimating distances that cannot quite be measured, reaching for the motion that might mean danger or interest or the passage of something worth attending to. The mind behind it is doing the same. It is composing, it is inferring, it is building, from the narrow facts of light and dark and the angle of a lamp, a picture that feels complete. Whether the picture matches what was there is a question worth keeping, not because the observer was careless or because the night was deceptive, but because the composing is always partly the eye's own work, and the night sky is the place where that work is most visible, most clearly the eye's own, most obviously pulled from the available dark, rather than simply received from it. A pilot, descending through the last 1,000 feet toward a familiar runway at night, watches the lights of the approach path come into alignment. On the left edge of his cockpit window, a single light holds steady, a red pinprick that has been there for the last several minutes, seemingly at his altitude, seemingly stationary, seemingly close. He has been watching it unconsciously, the way the eye always watches a light. It cannot immediately categorize. His hands are on the controls. The runway lights grow. The altimeter unwinds. The light on the left does not move. He touches down, feels the wheels hold, and at the last moment glances back at the light. It is still exactly where it was because it was always where it was, a tower lamp planted in the ground 12 miles away, broadcasting nothing but its own patient red. He had placed it at his altitude through the honest inference of a tired eye, with too little information and too much dark to work with. The lamp did not move while he descended several hundred feet toward the earth. He simply had nothing to measure it against, and without a fixed point to line it up against. The position he had assigned it felt as solid and certain as the runway itself. That is all it takes, a fixed point of reference, and the wandering stops. The light settles into its actual position, no longer drifting on the wall, no longer floating above the telephone lines, no longer grouped with the lights beside it into a formation it did not choose. When there is something to measure against, the eye finds what is there and holds it still, and the particular quiet that comes from having a thing in its actual place. That quiet is what careful seeing, in good conditions, reliably produces. Someone steps out of a lodge onto the open plain, and the cold comes first. It arrives before anything else, before the dark, before the width of the sky, before the sound of nothing in particular settling over the grass. The cold is the specific cold of a high plain in the hours after midnight, dry and total, the kind that makes the air feel thinner than it is, and the stars feel closer. And then, once the eyes have adjusted, and the body has remembered what it is to stand in that much open space, there is the sky, wide and depthless, and carrying more light in its upper reaches than any enclosed place ever holds. A person standing in that cold, on that plain, in that particular kind of dark, has been standing in exactly this way for a very long time. Not this person, not this night, but people like this, in places like this, watching lights that move without explanation through the enormous dark above them. The light that crosses the sky on this particular night moves slowly. It does not flicker. It does not arc or trail or leave a mark on the air. It holds its own brightness, drifting through the dark the way a thought drifts through the period just before sleep. Present, unhurried, not quite catchable. In certain Lakota Sioux traditions, lights of this kind are understood as the Wakanyan, the thunder beings, whose relationship to the visible world includes appearing as light and departing as light, and requiring from the person who sees them a quality of attention rather than alarm. The light on the plain does not produce alarm. It produces stillness. The person watching it goes quiet in the particular way that comes from encountering something that does not need anything from them. The light passes, the cold remains, the sky holds its position above the grass. This is one of the oldest ways a human being has stood in the world, not helpless before it, not frightened by it, but attending to it, present with it, returning its attention in whatever way a person returns the attention of a sky. The Lakota traditions that address these lights are not the only ones. They are not even the oldest ones. They are simply one of the places where the human habit of watching the sky and finding the sky worth watching is preserved in a form that has lasted across the full span of time that people have been standing outside at night with their faces tilted upward. The lights have kept appearing, and the record of that watching in oral tradition, in monastery chronicles, in clay tablets, in silk, is itself a kind of light, steady, persistent, crossing every kind of dark. The Tinglik peoples of the Pacific Northwest, and the Kwakwakwa, and others whose territories follow the great coastlines of what is now Western Canada and Alaska, have long held cosmological traditions in which luminous phenomena in the sky mark not threat, but transition, transformations between one state of being and another. The sky in these traditions is not a ceiling above the world, but a part of the world itself, a region that things move through, a threshold that light can cross. When a slow light appears above the tree line or above the water, it is not evidence of disorder. It is evidence that the world continues to move through its own processes, many of which a person standing on solid ground will perceive only as light, only as motion, only as something that was there and then, gradually, was not. The watching is not investigation, it is participation. These traditions did not develop in the absence of explanation. They developed as explanation. The slow light crossing the sky above a Pacific Northwest village at the edge of winter is not a mystery requiring resolution. It is a known thing, understood within a framework that places the human observer inside a world that is itself alive and in motion. What the oral traditions of many indigenous nations share across geography and language and the particulars of their specific cosmologies is this quality of attending to the sky without requiring it to be smaller than it is. The lights are documented. The pattern of their appearing is known. The meaning of that appearing is held not as a problem, but as a kind of relationship. On a night in the 10th century, in a stone monastery, somewhere in the low hills of Central Europe, a monk walked from his sleeping cell to the monastery garden because he could not rest. The hour was somewhere in the depth of the night, past compline and well before matins. The other brothers were sleeping, the garden was empty and cold, and the sky above it was the particular dark of a night, with no moon. What he saw standing above the city to the east, a pillar of pale light, vertical, holding its position above the rooftops for approximately the duration of 3 complete prayers. He would write down the following morning in the scriptorium, pressing his quill carefully into the vellum, choosing his Latin with the care of someone who understood that what he wrote would be read by people who had not seen what he had seen and would need to be able to see it clearly in his words. The monastic chronicles of the 8th through 16th centuries contain many such accounts. They are preserved in ecclesiastical histories and church records across the full geographic range of medieval Christian Europe, from the monastery houses of Ireland and Britain across to the scriptoria of the Holy Roman Empire and down into the Italian peninsula and the Iberian coast. The monks and bishops who wrote these accounts were educated men by the standards of their age. They understood the difference between what they had observed and what they believed the observation to mean. A pillar of fire seen above a city in a particular year, noted carefully with the month and the duration, and the names of others who had witnessed it, interpreted as a portent preceding a battle or the death of a king. This interpretation was wrong in ways that later centuries would be able to identify with more precision. The observation itself was often precise. The ecclesiastical vocabulary for aerial lights was rich and specific. Crosses of fire, burning swords, pillars, celestial armies arranged above the horizon. The interpretive framework applied to these observations belonged entirely to its own time and its own cosmology. But the observations themselves, the duration, the color, the position, the motion, the absence of sound, the testimony of multiple witnesses, these share something recognizable with accounts recorded before and after them in languages and traditions that had no contact with medieval Christianity at all. The lights themselves do not change their behavior to accommodate the frameworks people bring to them. The frameworks change. The lights continue. In Japan, the tradition of luminous aerial entities is one of the most extensively documented in any culture. The classical literature, the illustrated scrolls, the regional legends collected over centuries, all contain descriptions of lights that move through the night air in ways that do not correspond to stars, to fire, to lanterns, or to any manufactured illumination. The Hitodama appears in dozens of texts and artworks as a floating ball of fire, typically blue or yellow, understood as the soul of a person recently dead, moving through the world during the brief period between death and departure. Its appearance is not alarming. In these accounts, it is recognized. It is greeted, sometimes with quiet sadness rather than fear, because it is understood to be something specific, a particular person in a particular transitional state, visible for the last time. A woman standing at the edge of a marsh path in the Edo period would know what she was seeing. The small cluster of cold lights drifting low above the water, moving slowly in the direction of the village graveyard. These are onibi, the small flames associated with graveyards and marshes, and the borderlands between the living world and whatever comes after it. She would watch them with the calm of someone who has grown up hearing exactly what such lights are and where they go. Not calm from indifference, calm from familiarity. There is a kind of knowledge that produces stillness rather than agitation, and the woman at the marsh path has that knowledge. The lights move past her, the water holds their reflection for a moment, and then releases it. She continues on her way. The Kitsunebi, the foxfire, appears in Japanese classical texts and artworks across many centuries, described as a procession of hovering flames, small and cold and organized, carried by supernatural foxes during their nighttime gatherings. It was depicted in illustrated manuscripts and scroll paintings with a precision of visual detail that suggests observation as much as imagination. The specific quality of the light, its arrangement, its movement through low-lying terrain, its tendency to appear and then to simply cease, leaving no trace in the air where it had been. The foxes themselves were understood to be kitsune, beings of great age and intelligence, whose relationship to the visible world was one of partial presence, there, and not entirely there, visible by their lights more often than by their bodies, marking the night with something that required attention without requiring response. Across these traditions, there is a recurring quality. The light is seen, the light is noted, the light is held within a framework of meaning that does not flatten it into a problem. The meaning changes across cultures. The lights described with enough specificity share recognizable properties. This is not evidence of any single explanation. It is evidence of a long and continuous relationship between human beings and the sky they live beneath, a relationship in which the sky periodically produces something that resists the categories available to the people watching it, and the people watching it find, over time, something to call it. Long before the medieval monks were pressing their quills to vellum, and long before the classical period of Japanese literature, the Babylonian scribes of Mesopotamia were keeping records of the sky with a precision that was, by any standard, systematic. The Enuma Anu Enlil is a canonical series of omen tablets compiled as early as the second millennium before the Common Era, containing approximately 7,000 individual entries. It is one of the most comprehensive administrative documents of the ancient world, and a significant portion of it is devoted to the sky, stars, planets, comets, eclipses, the colors of the moon at different points in its cycle, the appearance of unusual lights above specific cities. All of this was documented with the care appropriate to information that carried political and administrative significance at the highest level. A Baru scholar in the palace at Nineveh would unroll a clay tablet in the lamplight of a room whose walls recorded the deeds of kings who had been dead for generations. The tablet he was reading described a hovering light seen above the city on 3 consecutive evenings in the month of Tishri. The color of the light was noted as the color of heated copper, which is a specific and considered observation, not red, not orange, but the particular shade of a metal in a specific state of temperature. The scholar would compare this entry against the interpretive columns of the Enuma Anu Enlil, which mapped the appearance of unusual aerial phenomena against anticipated events in the political and agricultural life of the kingdom. The interpretive framework, like that of the medieval monks, belonged to its own time. What surrounded it, the month, the city, the duration, the color like heated copper, the 3 consecutive evenings. These are empirical notations made by someone who understood the value of precision. The correspondence between Babylonian administrators and the king includes letters from Baru scholars in cities across Mesopotamia reporting unusual aerial observations and requesting interpretive guidance from the palace scholars. This correspondence is preserved. It is not mythological. It is administrative, and within it, recurring across centuries of observation, are descriptions of lights above cities, lights that hovered, lights that moved, lights that appeared on consecutive nights, lights that were noted as anomalous, even within the already extensive catalog of what the Babylonian sky was known to produce. The scribes who recorded these events were not recording wonders. They were recording data within a data collection framework that had been operating for centuries before them and would continue operating for centuries after. There is something specific about the phrase 3 consecutive evenings. It appears in the Babylonian record. It appears in this video's title. It is not a coincidence that this particular detail has persisted across so much time as the specific pattern worth noting. A light seen once might be anything. A light seen twice might be a coincidence. A light seen on 3 consecutive evenings above the same city is something that requires an entry in the record. The Babylonian scribes understood this. The people who have reported recurring aerial lights over cities in every century since have operated on the same intuition. Once is a question, twice is a pattern beginning, 3 times is something that deserves to be written down. The Chinese tradition of recording unusual sky events is one of the longest continuous records in human history. The Imperial Astronomical Bureau, which operated under successive dynasties across more than 2,000 years, maintained a systematic program of sky observation and documentation, whose scope was enormous. Official astronomers stationed in capital cities and major provincial centers made nightly observations and recorded anomalies in texts that became part of the official dynastic histories, the Shiji, and the histories compiled by the Imperial Bureau under Han Dynasty supervision and after. These records were not popular accounts. They were official documents maintained by trained observers under institutional mandate, subject to the same standards of precision and accountability as any other administrative record of the empire. The historian of science Joseph Needham, working through these texts over many decades in his series on science and civilization in China, found within them numerous entries describing recurring luminous aerial events over specific cities and river valleys, events that were noted as anomalous even by the scribes who recorded them. This is worth attending to. These were people who knew their sky in extraordinary detail. The official astronomers of the Imperial Bureau were among the most careful observers of the night sky that any civilization has produced. When they noted something as anomalous, they meant it against the background of that knowledge. The event fell outside what their sustained attention had established as normal, and they said so in the careful language of the official record, and they continued watching. A recorder at a writing desk before dawn in the Han Dynasty, the brush moving carefully across silk, setting down characters that describe a guest star seen on the 3 previous nights hovering above the river city, would pause, perhaps, before adding the note that the scribes of 2 generations before him had recorded something of the same kind in the same season. This is a careful, considered observation. It is the act of a person who understands that the sky has its own patterns, and that those patterns may extend beyond any single human lifetime, and that the work of the recorder is to make the pattern visible across the time that separates observation from observation, generation from generation. What the person holding the brush understood in that hour before dawn, with the lamp burning steadily and the silk beneath his hands, was that the record outlasts the recorder. The sky, in this way, keeps its own records. The Bureau's task was to keep pace with them. There is a quality of attention that emerges across all of these traditions that is worth holding for a moment in its full simplicity. It is the quality of a person who has decided that the sky is worth watching. Not watching for a reason, not watching toward an expected conclusion, but watching because the sky is where the lights are, and the lights are real, and whatever they are worth the sustained attention of a careful person who keeps a record. The Babylonian Barrow scholars, the Benedictine monks, the Edo period woman at the marsh, the Lakota observer on the open plain, the Han Dynasty recorder with his brush, none of these people were watching the same sky in the same way or with the same framework of interpretation, but they were all watching, and they all wrote down what they saw, or sang it, or carved it, or wove it into the traditions that would carry the observation forward into the time when others would take up the watching. The oral traditions of many indigenous nations are often described as if they existed in contrast to the written record. Older, less precise, less verifiable. This comparison does not survive much examination. Oral traditions that have been maintained with care across many generations carry within them the same qualities that make any record valuable: precision about specific details, consistency across multiple witnesses and transmitters, a framework for distinguishing what is regularly observed from what is genuinely unusual. The Lakota traditions that address the Wakanyan, the Thunder Beings, carry detailed information about the conditions under which their lights appear, the seasons associated with them, the appropriate response to their appearance. This is not mythology in the sense of decorative narrative. It is observational knowledge, organized for transmission across time, carried in a form suited to the social and environmental conditions of the people who maintained it. The Pacific Northwest peoples, whose cosmological traditions incorporate luminous sky phenomena as markers of transformation between worlds, were living in a landscape where the relationship between sky, weather, ocean, and land was intimate and consequential. Their traditions about what lights in the sky mean are traditions developed through sustained observation in specific geographic conditions, the particular quality of light above cold water, the behavior of luminous phenomena near coastlines and fjords, the way certain lights appear in certain seasons. The traditions are inseparable from the landscape that produced them. The knowledge is embedded in place in a way that no purely documentary record quite achieves. Across medieval Europe, the ecclesiastical records of unusual aerial lights are sometimes read now as evidence of how the educated minds of that period misinterpreted natural phenomena through a theological lens. This reading is not wrong. The interpretations were wrong in ways that can be identified, but the reading misses something. The monks who wrote these accounts were doing something real with their attention. They were bringing to the sky the best tools available to them: observation, memory, the written word, a tradition of careful documentation, and they were doing this in institutions specifically organized around the preservation and transmission of knowledge. The fact that their interpretive framework was wrong does not diminish the fact that they looked and counted and measured duration and asked other people what they had seen and wrote it down. These are the acts of inquiry. The conclusions drawn from inquiry can be revised. The inquiry itself endures in the record it produces. The Enuma Anu Enlil is approximately 4,000 years old at its oldest layers. The Chinese dynastic histories span more than 2,000 years of systematic astronomical observation. The monastic chronicles of medieval Europe cover roughly 8 centuries. The oral traditions of the Lakota and the peoples of the Pacific Northwest carry observation whose depth is difficult to date with precision, but which represents, in many cases, thousands of years of accumulated watching. Against this background, the institutional investigation of unexplained aerial phenomena over cities that began in the mid-20th century is very recent indeed. It has been operating for perhaps 80 years. It has produced significant documentation. It has not resolved the question it set out to resolve. This is not a failure of method. It is a statement about the timescale of the question. The questions that have persisted longest in human experience tend to be the questions that are genuinely open, not open because no one has tried to answer them, but open because the thing being examined is real and complicated and does not simplify on demand. The lights that have appeared over cities across every century of recorded human history are real in the sense that many people have seen them. They are complicated in the sense that the frameworks people have brought to them have not in any century fully accounted for them. The question remains open, not because it has been neglected, but because it has been taken seriously, generation after generation, by people who looked up and saw something worth writing down. The cold comes first, always on the open plain at night. It arrives before the dark fully settles, before the eyes adjust to the width of the sky, before the sound of the wind across the grass establishes itself as the only sound. A person stepping out of warmth into that cold stands for a moment in a kind of threshold state, the body still carrying the temperature of the interior, the skin beginning to register the outside air, the eyes adjusting, the mind releasing whatever it had been holding in the warm and enclosed space behind. In this threshold, something loosens. The categories that organize a lit and inhabited room become briefly less insistent. The sky, which is very large and very old, becomes briefly more available to plain attention. This is the condition in which lights in the sky have always been seen, not in crisis, not in panic, but in the particular quiet of a person who has stepped outside for a reason or for no reason, has looked up because the sky is there, and has found something moving through it that does not fit the available explanations. The response, across the long record of human observation, is more often stillness than flight, more often curiosity than alarm. The Lakota observer stands and watches. The monk goes back inside and reaches for his quill. The Babylonian scribe notes the month and the color of the light and the number of consecutive evenings. The woman at the marsh path watches the Onibi drift toward the graveyard and continues on her way. The Han Dynasty recorder adds a note that this has happened before in the same season, and that the sky, in this way, keeps its own records. There is something deeply restful in that continuity. Not restful because it resolves anything. The lights have not been explained by their persistence, and the record does not close the question.